Hello, Brad. So, thank you for your video that you have provided. And basically, what you propose is the most straightforward way as the flexibility in Inventor should work. Only problem is that this approach is not stable. I have tried it many times, and many times it has proven to be not stable. So, uh, I have prepared the assembly of this element, and in master positional representation I have added a constraint that fixes the rotation degree of freedom. I have left the rotation degree of freedom free deliberately last time. I will not get into detail why, but now I have reduced it, and as you can see here, this assembly, as in your video, has only one single degree of freedom, that is translation of this element, and it has a single side range constraint that only limits the minimum distance between these two elements. I could apply the other range for the other direction, but this time I do not need that. I will I will leave it as it is, and I will now open the main assembly. I am working on the same dataset that I have made available for download. So in the master assembly, in the master positional presentation, we have this. When I switch to transport, everything looks the same. So this, where is it? Where are you? Oh yeah, here we are. So in this, I have, this is not that, oh yes, this is this one. So in this positional presentation, I have applied the closed positional representation of the extension piece, because let's call it the prop, because in this positional representation this end is not fixed. It is basically not the constraint with this axis is suppressed, because this will be brought to closed position, and in this alignment it will be transported. So this end lands where it is let's say driven by the length of the extension node and the position of this element. When I switch from transport to unfold, I am getting the same as before. So this has an angle of 85. Where is it? This has an angle of 85, but this one didn't update. So it is flexible. I will switch it to master. For some reason I cannot do it. Override. Why is it not? Okay, when I switch it to master, it is basically as it's supposed to be. When I switch to unfold, it is then okay. So now what I will do, I will copy that and I will switch to that, and now what I will do, I will override the angle to 160, and what happens is it doesn't update. The angle is not 160. The assembly is not representing the alignment I have just set. So basically the solution is again, as previously, not following the constraints defined. And what I will do now, I will take that and drag it a little bit with a mouse to force the assembly to update. When I do that, as you can see here, this gets the position it should, but in the same time this extension rod is obviously brought out of the constraints defined in that, because this, if we use the half section view, and we will get in the middle of that, so we now see that the mate constraint with range between, I will switch to surfaces, feature select faces, between this face of the threaded piece and this face of the fixed piece is not followed now, because this, if you remember this constraint, I will open that. This constraint is defined so it connects this face and this face with a minimum distance of 0. So the closest as it can get is here. It should never be allowed to go inside the casing. And again, this time it updated that, but this time this constraint axis to axis is not followed. So where is it? So not this one. Where is the other one? This is strange. This is not that one. So where is it? Okay, so obviously now this constraint is not being followed because it is constraining this axis with the other one, and obviously it is not followed now. So whenever you use flexible assembly like that, it is certain that in some point constraint solver will bring the assembly into the position against constraints defined. This will either be internal constraints of the flexible assembly or the top level assembly constraints between elements, not necessarily between flexible and not flexible assembly. If I now drag that, you see it is again, and now we have this constraint followed, but we do not have this constraint being followed, and we do not have the actual constraint of this one. So every time I do something, it is not solving the assembly properly because it is not catching the fact that it is not following the internal or top level constraints. So basically design doctor fails totally on the line, and constraint solver also is not working perfectly because either it solves the equations badly, or what I believe, and I said it many times, is more likely the data prepared for the constraint solver is not adequate with the defined constraints. So this is not working. I will now bring it into the position that it is not in conflict. So I will get it 85. It updated, and now what I will do, I will try to drive this constraint from 85 to 150, let's say. I will set, let's say, 5 degrees increment, and I will hit to run that. You see, we are getting that the constraint solver cannot solve the assembly near this point. So this is obviously an indication of the fact that the constraint solver is not capable of finding what is wrong. Normally, when you drive something against the constraint, it says there is a conflict. So I will try the other way. Let's say 80. and now again. So we are getting this, that it cannot be solved. So basically this is not correct, and I am forcing it to let's say to 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 show this kind of errors in a deliberate way, but very often it is like that you are getting an error which is not expected. Now I expect this to fail, but or I do not expect this to fail, but I expect to get the proper indication of the constraints being in conflict, not that the assembly cannot be solved. I expect this to not to crash, and to first of all to indicate that it is not working, because if I put 160 again here, first it is not updating, so it says it is 160, it doesn't show an error. When I do that, it crashes the assembly that is inside, and basically now I do that, but I will get it back, so I will undo that, and now having this constraint that is not followed, I will change some other constraint in the assembly. Let's say I will from 25 I will go to let's say 30, and again it is not updating, it didn't update to 30, obviously it is now 25 as it was. So you do not see something is wrong, but the software gets basically very wrong. I will now go to the master, and I will now go and apply another constraint that I will use. So I will apply that. It is now set to 25. I will go here. I am getting an error message, and again I am getting bad positional representation, but I will, and now it is back again, but I will, and now even if I change that to something that works, it is not following. I will make it 25 again, and now it should be okay. I will now make it 160 again to have the solution that is not valid, but the constraint solver and design doctor does not show any signs of problem, and I will now deliberately make another change. If I accept that, I do not have the design doctor showing me an error again, although I have a sick constraint here. If I do anything, it is crashing again. So this approach does not give a stable environment for the assembly. Once the assembly is crashed, this one is very simple, but if you have a bigger assembly, once it is crashed, it is often crashed to a point where it is not possible to restore the assembly into the state where it is usable. So there is a bug in flexible handling, in handling of flexible components in Inventor, and Autodesk should look into it and should fix it finally, because it is possible to get it. The constraint solver is capable of solving those equations, only it has to have a data provided in a way that it is usable for the solver.